Yeah, okay. Tell me what we have studied, students. What did we cover last class? Yeah, electrode potential, then standard electrode potential. What is standard electrode potential and what is the difference between normal electrode potential and standard electrode potential? Yes, you still have to check the notes, not studied. See, I'll tell you one thing. Any other chapter, if you don't read it, maybe it might not make a difference. But this is a topic where you tend to forget, correct? If I ask you what is cathode now, what is anode now, which side is positive, which side is negative, will you be able to answer? How many of you will be able to answer without looking into the books? Cathode side is positive or anode side is negative? Huh? No, I'm asking which is what. I'm not saying the cathode is positive, anode is negative. Anode is positive and cathode is negative. That's what we have studied. But in case of Daniel cell, what did we study? See, that's what I told. In Daniel cell, don't you remember we have done? See, I know cation goes to cathode. So if cation is positive, cathode should be negative. But I told you in case of Daniel cell, it will be the opposite. At least remember the concept, not the things what you studied. What was this side in zinc and copper? Zinc. Okay, zinc was here. Zn2 plus. Here it was Cu2 plus 2. Cu, which is cathode, which is anode. Zinc is anode and this is cathode. So, where exactly is negative charge, where exactly is positive charge? Why does it look dull today? That light has gone? Ah, thanks. Yes. See, I told you negative charges goes on accompanying in which electrode? This electrode. That's why I told you this will become negative, correct? Here, there will not be electrons. There will be positive charges that is getting accompanied, so it will be positive. Clear? These are the small things. If you don't revise, you will tend to forget. Okay? So we'll start. I just want you to recall the last thing, that is what is E cell and what is E naught cell. Yes? Uh, Maybe you can check the previous videos. If you have any doubts, you can come back. Okay? What is E cell, students? Quickly tell me what is E cell. Not mathematically. Tell me what is E cell. If I consider this has certain potential, a cathode is also having certain potential. What is the total potential of the whole cell? What is potential? Electrode potential. What is electrode potential? Ability of an electrode to gain or lose an electron. At which spot? At the interface between the electrode and the electrolyte, or we can also call it as metal and electrolyte. Okay. So we have a formula, right? Tell me what is the formula? E cathode. E cathode minus E anode. Or in this case, easier to remember it is E right minus. That's what you have written. So it is E right minus E left. Okay, till here we have studied. At least you remember till here. Now, imagine I don't know one of these. To calculate E cell, do I require both? I need to know both the cells. So imagine I know only one of the cells potential and I don't know the other cell potential. What will you do? What can we do? Can we take help of somebody else to help us to find? Yes. So write down the heading for today. Standard hydrogen potential or standard hydrogen electrode, SHE, she, standard hydrogen electrode, standard hydrogen electrode. Yeah. understand what is standard hydrogen electrode, and then we'll see why it is used. Yeah, by the way, how was the test? Were you able to write? I gave an easy test. It was not tough. Yeah, you are shaking your head. You have not written the test, right? Problem were you able to solve? Yes, the delta. What was the question? Freezing point question was given to you, right? And one more was molarity, I believe. Okay, I'll see what you have written. So, standard hydrogen electrode acts as a reference electrode. Now, who is a reference? Tell me. When you go to a company, you might tell someone has referred you. So, can I tell someone who is helping you? Yes, referring. Someone is telling you, okay, you are supposed to do so and so things. So here, this standard hydrogen electrode acts as a reference electrode, because of which if we do not have one, we can find the other with the help of this electrode. So in order to understand how this acts as a reference electrode, should we know the working of this electrode? Yes. So standard hydrogen electrode consists of three things. What is PT? Give it. Platinum electrode. Then it has, what is H2G? Hydrogen gas. What does this mean? Hydrogen ion. So if I'm taking hydrogen ion, who is the one who gives H plus ions? Acids or base? Acids are the one who gives H plus ion, right? Okay. So we are considering a beaker which consists of a platinum electrode. What is this? This is your platinum electrode. Okay. Here there is an inlet for hydrogen gas to pass through of maybe 1 bar. Why am I considering it as 1 bar? Anyone, can you tell me why it is 1 bar and not any other value? It is standard hydrogen potential. Last time we had studied something about standard, right? What else standard did we study last class? Where temperature was 273 Kelvin, whatever that, pressure was 1 bar, volume was 1 molar. What was it? Yeah, concentration. What is the heading? What did we learn there? Standard electrode potential. Yes. So similarly, whenever we say standard, certain conditions should be in a standard format. Here, the electrolyte that we use is an acid, H plus, which gives H plus ion, and this has 1 molar concentration. Yes, two things are clear. What is here? You are having hydrogen gas, which is of 1 bar. You are having H plus ion. It can be HCl. Okay, usually we use HCl ions. Why am I writing HCl is giving H plus? Simple chemistry. HCl is giving in aqueous solution H plus and Cl minus. Clear? So now this is taken as 1 molar. I hope you are clear. Why is it 1 molar? Because it's a standard hydrogen potential. Now listen exactly what is going to happen. Here, who is the one here? Platinum electrode, or platinum is powderly that has been arranged in the electrode form. Now what happens is, when hydrogen gas is passed through here, hydrogen gas gets absorbed over the platinum electrode. What is absorption and adsorption? Do you know the difference? There are two things. What is it? Absorption and adsorption. Have you studied surface chemistry? No. When I'm writing on the board, does the chalk goes only on the surface or does it percolate inside? Only the surface. So the surface phenomenon is called as adsorption. Imagine I put the same chalk inside a ink bottle. Will the ink go inside now? Yes, ink will go inside the whole chalk. Correct? That thing is called as absorption. So did you understand the difference? One is absorption, one is adsorption. See, when you get new bottles, there is one sachet that is placed inside, no? What is that? Silica? Yes, silica gel, or it is also alumina. What does these people do? They adsorb. Adsorb what? Moisture. They trap the moisture. So if you see it will not be wet, will be wet, or it will still be dry. So what happens there is absorption. Now why did I take this concept of absorption and adsorption? Hydrogen gas get adsorbed. Adsorbed means it is going into the surface or inside? Surface. So surface of which case? The platinum electrode. So imagine you're continuously sending hydrogen gas to the platinum electrode. Some of them gets stuck over there. What will the rest of them do? Rest of them starts bubbling out. Will they bubble? That is the normal. Now, if you put a gas inside the solution, it starts bubbling. So here, two things happen. One is gas getting converted into H plus ions. H plus ions again evaporating and getting converted into gas. So what else is happening here? Tell me. H2 getting converted into H plus. This is aqueous. This is gas. What is the next thing that is happening? H plus aqueous gets converted into H2 gas. Okay. Now tell me what is this and what is this? Is there a phenomenon that is oxidation or reduction happening in any of these? Okay, to be very frank, let us consider this half H2. Okay. Just to consider hydrogen H2. Do not see the half at all. H plus, H2 is getting converted into H plus and H plus is getting converted into H2. Where is oxidation happening? Where is reduction happening? Which is reduction, which is oxidation? Okay, tell me what is oxidation? Loss of electron. Leo is your oxidation. Loss of electron is oxidation. What is gain of electron? Reduction. So, imagine I had no vacancies. H2 means neutral. No vacancies. Suddenly there was a creation of one vacancy. So electron got removed or added? Electron got removed. So loss of electron is oxidation. So this fellow is undergoing oxidation. Clear? Yes. Now there is one vacancy. Suddenly vacancy gets filled. What is this called? Reduction. Now go back to your previous classes. Think about two species I told you. Oxidation is related to and reduction is related to. Yes, which is related to cathode, which is related to anode? Red cat. So reduction is related to cathode and this one is anode. Anox. Now, why did I tell you the whole story here? Can I tell you that standard hydrogen electrode has the capability to act both as a cathode as well as an anode? Yes. What are the two reactions happening? Both oxidation and reduction. So both can take place. What's it? When both the reaction can take place, it can act as anode as well as cathode. Yes. So write down. Start writing. Standard hydrogen electrode. Write down this thing. This whole equation. Because I need to rub. That's why. Then you draw this. And I'll tell the story. Do not write this section. Just write this part. This class is more difficult than the last hour of the college. Yeah, right? All are half dead. What can we do to awake you all? Let me know once you have completed drawing this picture. Today there was no leave because of rain. Yesterday, last year I remember till PU they got almost 10-12 days of holidays. And then later they had to suffer because they had to come Saturdays full day, right? Some of the colleges had to adjust for the leaves, right? Yes, are you done drawing? Okay, now write down. Quickly write what we have studied, okay? What is it? Standard hydrogen electrode, you can just write SHE, capital SHE, SHE consists of a platinum electrode dipped inside, platinum electrode dipped inside what? A solution of H plus ions, a solution of H plus ions. In bracket you can write HCl, an inlet, full stop. An inlet is provided, an inlet, INLET, an inlet is provided where hydrogen gas, of 1 bar pressure, hydrogen gas of 1 bar pressure is allowed to flow in, is allowed to flow in, full stop. Some of the hydrogen gas particles, gets absorbed, okay, gets absorbed on the powdered metal. Which is the powdered metal here? The platinum, okay. So why is it powdered, students? If it is powdered, the adsorption capability is increased, because when the surface area increases, adsorption increases, correct? No, imagine you are drinking water in a this much small glass, and if you are having water in a very huge vessel, which will tend to cool down fast? The bigger vessel, right? Why? Because surface area is more particles can exchange the energy or heat. Where did I stop? Adsorbed on the powdered metal, full stop. The remaining gas particles starts bubbling in the solution, starts, starts bubbling in the solution to give rise to H plus ions, to give rise to H plus ions, full stop. These H plus ions, these H plus ions further gets converted into, further gets converted into what? H2 gas. Yes, it gets converted into H2 gas. Full stop. The following reaction takes place. The following reaction takes place. The following reaction takes place. Write down the first reaction, half, only first reaction, okay? Half H2 gas gives H plus aqueous. That's the first step what we studied, no? Right? Gas gets converted into, bubbling into the liquid. H plus aqueous. Did you write this reaction? Write down. Here, oxidation takes place. Here, oxidation takes place. Here, oxidation takes place. And hence it acts as, it can act as what? If oxidation is taking place, it can act as a anode. full stop. Next, write down the second reaction. H plus aqueous gives half H2 gas. This undergoes here it undergoes what reaction? Reduction. It undergoes reduction. Hence, it can act as cathode. Okay, listen here now. If I consider this as E cell or anything, how do you write the cell reaction for this? I have told you how to write the E cell, no? How do you write? E half H2 bar H plus. This is one, correct? Second one, E H plus. Okay, here you are supposed to write aqueous. Here it is. Sorry, gas aqueous. What is the other one? H plus aqueous bar half H2 gas. The peculiarity about the standard hydrogen electrode is the potential will be zero. What is the main characteristic here? The potential. Why it is zero? Will it have any value when it is acting both as a cathode and an anode? No. So the total potential here would be zero. Write down next line. The electrode potential both at cathode and anode, both at cathode and anode will be equal to zero at all temperatures, will be equal to zeros at all temperature. Yes, then write down these two equations. You can even write it as E naught. That would be more because since it is standard, we'll go with E naught. So E naught half H2 bar H plus is equal to 0. E naught H plus bar half H2 is equal to 0. Clear? Any doubt this side, students? Done. Now I want you to write the reaction for cathode half cell reaction and anode half cell reaction for this. I have already written it. You just have to write it again. Write down cathode half cell reaction. Cathode half cell reaction. Which will be the cathode half cell reaction there? H plus is giving H2, right? Okay, write down H plus aqueous gives half H2 gas. See, I'm making you write again and again because they can ask you in any way. Correct? You should be able to understand that everything is the same thing. So, which is the cathode half cell reaction? This is cathode half cell reaction. Now, after writing this, write anode half cell reaction. Anode half cell reaction. Yes. Then students, can we quickly revise what we studied in standard hydrogen electrode? Yes? Okay, tell me what are the three things that we require in the standard hydrogen electrode. One is platinum, which is a solid. Then we require hydrogen gas as well as H plus in aqueous. Yes, and what do we use here? H plus is from which acid? Hydrochloric acid. Do you know the setup? What is the setup? We have a platinum electrode dipped in HCl. Yes, of how much? 1 molar. Yes, and the hydrogen gas is passed through the inlet and the hydrogen gas is of pressure 1 bar. What happens to this gas now? It starts getting absorbed on the platinum rod. But does all the hydrogen gas get absorbed? Sorry, absorbed? No. Some of it gets circulated inside the liquid. And when it gets inside the liquid, what happens? It gets converted into H plus ions. Now these H plus ions, will it stay stable? No, it gets again converted into H2 gas. So the reaction takes place continuously. That's why, do we have any potential? No. The potential both at the anode and the cathode will be zero. Now who acts as a cathode and who acts as an anode? Two things happens. One is hydrogen gas getting converted into H plus ion. This will act as H2 getting converted into H plus, oxidation or reduction? Oxidation. So oxidation means it acts as a anode. Now H plus getting converted into H2, reduction. So it will act as a cathode. Always remember red cat and ox. Yes. So is this clear about SHE? See, there are hundreds of reference electrodes. Have you heard of calomel electrode? No. Have you heard of okay, hydrogen electrode, mercury electrode, HgHgCl2? No. Maybe by this end of this chapter, we'll be learning about battery, fuel cells. So maybe that time you will learn it. Okay. Write down the next heading. Measurement of measurement of. Okay. Listen here. Why was the need to study SHE? I told you in the beginning. What was the need for SHE? It acts as a reference electrode. And why do you need a reference electrode? If we do not know any one section, in order to understand the other, we will take the help of SHE. I'll tell you how it works. First one right now, measurement of Mg magnesium using measurement of Mg using SHE. Measurement of Mg using SHE. So here what exactly is happening? Usually when we tell, I'm saying zinc as well as copper, okay? So zinc acts as either cathode anode, copper acts as cathode anode. Now here we are having only two species. Who are the two species here? One is magnesium, the other one is standard hydrogen electrode. So obviously who is acting as a reference electrode? Standard hydrogen electrode. But we have a choice. Imagine if I'm drawing a beaker, two electrode, one will be which electrode? Platinum electrode, that is SHE, correct? The other one will be magnesium. In which solution? MgSO4. This is in which solution? HCl of 1 molar. See, this experiment was conducted, and when the experiment was conducted, the magnesium sulfate that was used was also of 1 molar. So what is one peculiarity that you have to understand here? Both of them are having same volume. This much is clear. So last year you have studied something about redox reactions. Yes, I hope you have studied about redox reactions, and in that we have something called as reactivity series. Yes, do you remember there might be a beautiful box in NCRT which gives about how much is the reduction potential of each of the terms. So here, what is my choice now? I can either take magnesium sulfate as anode and SHE as cathode, or the vice versa. We observe that magnesium had a value of minus 2.36 as far as I remember. 2.36 volt. How many are sleepy here? All are dead. What can we do? This is an important topic. Hmm? I cannot stop the class. How much time do we have? One more hour? Again, it is going to be more difficult because you will all have classes again, right? Now, hardly only one college is here. Right, right. At least rather than listening, right. Uh, Magnesium. Did you write the heading? Here, here. But writing makes you more sleepy? No, more active? Here, I could make you awake, but since we are in live, I can't do that. You can do that. You can pause it. Yeah, pause. Quick, quick, quick. I might lose my job, but still. हाँ Okay, sorry for the inconvenience caused. But imagine I have to make this in 30, 40 students of class. Yes, the reason is the ones who are sleepy, now your brain has to think whether I have to tell the number or the name. Half awake, better than the previous one. Okay, can we start? Yeah, where were we? I don't know one more game. Now listen. Magnesium is dipped in magnesium sulfate. The other one is a reference electrode, and that is, which is the reference electrode? SHE. That is your standard hydrogen electrode. Okay. Now, from the set of values, what they got to know is magnesium has a value of minus 2.36. Now, just understand from the concept there, where do we have negative value? Anode. So I decide that magnesium will be taken as anode, and who will be taken as cathode now? FHE will be taken as cathode. If magnesium is in anode, what kind of reaction will take place? Oxidation. And magnesium undergoing oxidation, what reaction will it give? Mg will be given to Mg2 plus. How the Leydig reaction possible? Either Mg to Mg2 plus or Mg2 plus to Mg. I don't have to explain why this is Mg2 plus, right? Why? SO4 is 2 minus. So to nullify that you have Mg2 plus. So since it is taken as anode, now what will happen? Magnesium will get converted into magnesium 2 plus, and this is nothing but your oxidation. Now SHE, since it's a cathode, right? Cat. So it should undergo reduction. Check in your notes, when standard hydrogen electrode undergoes reduction, what is the formula here? Reduction. Gain of electrons. So it should be H plus aqueous giving. Does this make sense? Why is magnesium taken as negative? Why is it acting as an anode? Why it's acting as cathode? Till here it's clear. Now, what do we know about E cell? What is E cell? E cell is equal to E cathode minus E anode. One day I lose job for sure. What is E cathode now? Who is cathode here? SHE. So it is 2.36 minus 0. Is it correct? Thank God you are all alive. I wanted to check, that's it. I'm not sleepy. Where is it? Cathode. Who is the cathode? SHE. And I told you, SHE, irrespective of whether it is cathode or anode, what is the potential? 0. Yes. So it will be 0 minus 2.36. So what will be the final value? 2.36 volt. So finally you are getting E cell value as 2.36. Write it, Lisa. Then I'll explain. Is it understood? Should I explain again? Yes? Okay, quickly listen here. Where did we start? We have taken, I wanted to know what happens to the E cell where magnesium is dipped in one of the solution. I'll give you time, listen here. And the other beaker we are having standard hydrogen electrode. Listening? Okay. Now I have a confusion which should be taken as a anode, which should be taken as a cathode. But from the redox reaction chapter or from the reactivity table, I have standard reduction potential value of magnesium. What is it? Minus 2.36. What is the peculiarity about this value? It is negative. And whenever any species is negative, we know that negative comes under which place? Anode. So by this assumption, the scientists took magnesium to be the anode. So who becomes the cathode? Standard hydrogen electrode becomes the cathode. Yes. So if this becomes the anode, what is the reaction? Oxidation. Oxidation means Mg should get converted into Mg2 plus. That is loss of electron. Now who should gain the electrons? SHE. So that is the reaction written here. Clear? Now for the whole cell reaction, we have to know E cell. E cell, what is the formula? E cathode minus E anode. Yes. So E cathode, what is cathode? SHE, and SHE, irrespective of whether it is cathode or anode, what is the value? 0. So it will become 0 minus 2.36. Answer will be 2.36. Okay. Right till here. Then I'll explain. I have one request from you all. Monday class will be half an hour extra. Right? Because I'll be not there another class. So that's a good news, no? Yes. So Monday I'll take 5 to 7. Is that okay? Anybody has issue with that? Anybody traveling far? Where? Huh? Adyar. So what should we do? Yeah? Or else I have to take class on some other day because either on one Friday or Monday I'll be on leave. Okay, should I adjust some other class and take rather than making it late? I'll see. If possibility is there, then I'll do that. Okay, write it down quickly. You should stop drawing in scale. This is not exam. You should just do rough drawing and finish it off. On paper, yes, the prettiest the paper is, that good it is. Yes, imagine you are a faculty. Which paper will you like more? The one which is scribbled or one which is written neatly? Huh? The ones who are telling scribbled, maybe are you writing in scribbled way? Okay. Maybe in another class I'll tell you how to score better marks by your presentation. Correct, no? How to fool an examiner. But you have to study. Paper ಮಾತ್ರ ಚಂದಾದ್ರೆ use ಇಲ್ಲ. At least you cannot write things inside, no? Are you done, students? I thought we'll finish too many topics here. We are still in second topic. Huh? So I'll take 10 minutes extra. Huh? What is this? I gave my 10 minutes for you, right? So that you come back to normal. Allah. Now don't start thinking I'll take 10 minutes extra. At least be fine till 6:30. Done? Okay, can you all write a sentence? If the standard electrode potential, if the standard electrode potential, below this you will write, if the standard electrode potential is negative, if the standard electrode potential is negative, then hydrogen gas is more stable, then hydrogen gas, then hydrogen gas is more stable, hydrogen gas is more stable than the reduced form, than the reduced form, than the reduced form, full stop. What does this statement tell you? Do you understand anything from this statement? No, you will not. Listen back. Come here. Magnesium was given a value of minus 2.36. It's negative. Yes. And when it is negative, we know that it acts, it becomes what? Oxidation reaction takes place. Now, if oxidation is taking place in magnesium, will magnesium itself act as a reducing agent or a oxidizing agent? What is my question? I am undergoing oxidation. So, I will be a good reducing agent or good oxidizing agent? How many are saying oxidizing agent? How many are saying reducing agent? Why? Because if you are reducing agent, you will help others undergo reduction and in self you will undergo oxidation. So understand that the more negative the value, the more oxidation will take place, the better it's a reducing agent. Same thing is told there, but they have compared it with, what is it, SHE, and they have told that its reduced form will be more stable. That's it. Okay. If you don't want to learn that line, that's okay. But at least will you understand this concept? Do you want to write that? Yes. The ones who want to write, please write down. The more the negative value, the more the negative value, the more the negative value of standard reduction potential, SRP, standard reduction potential, what will happen? The stronger reducing agent it will be. The more negative the value of SRP, the stronger the reducing agent. I'm not explaining the complete system, but you have understood, right? Why it will become stronger reducing agent? Because it will undergo oxidation. Why will it undergo oxidation? Because it will be in anode. Yes, clear? Now write down next one, measurement of copper. Measurement of copper. Now magnesium was done. I have to check what will happen for copper. Okay, so Cu dipped in which one? CuSO4 in one more beaker. What is it? SHE. Now I don't know which is to be what. So I'm not me. The scientist decided that now SHE will be taken as anode and this will be taken as cathode. They reversed it to check whether it will still work or not. Okay. So if it is taken as anode, what will be the reaction? It will undergo oxidation. Tell me the reaction in oxidation. Ah, H plus getting converted into H2. Half H2 aqueous getting converted into. How many of you are not aware of this one? Why this is taken as this? Everybody clear? Yes? Okay. Now what will be the reaction here? Cathode. So reduction. This is Cu, here it is Cu2 plus. So will it be Cu to Cu2 plus or Cu2 plus to Cu? Reduction. So gain of electron. Two vacancies were there. Now there will be no vacancies. So Cu2 plus aqueous will be giving us Cu solid. Till here clear? Now we write E cell is equal to, what is it? E cathode minus E anode. What is the cathode one now? Did I give you a value for E cathode? No. The scientist wanted to check what will happen if we don't know this value. So write it as E cathode minus, what is the value of E anode? 0. Okay. So when this reaction was taking place, there was a bulb, right? There was a voltmeter which will, what does a voltmeter do? Check the voltage. Yes. So it found that the whole E cell value was somewhere around 3.11 volts. So now tell me what should be the value of E cathode. So when they did the experiment, they realized that the current or the voltage that passed, not current, the voltage that passed was of 3.11 voltage. So what should happen to E cathode value? 3.11. Is 3.11 positive value? Will cathode be always positive in Daniell cell? So we taking this thing to be a cathode is correct. Imagine if I had taken something as cathode, something as anode, and at the end you get E cathode as negative. Will it be correct? No. E cathode should always be in positive. E anode should always be in negative. So this is how they were doing trial and error method to see which will go for cathode, which will go for anode. Can you quickly write it till here? In the previous one, hydrogen was more stable than the reduced form, right? What you have written? Hydrogen is more stable than the reduced form. So here it will be the opposite. Weather is sleepy plus AC. Good reason to sleep, right? I'm aware of students who would be sitting in class when it is rainy season. Nice Maggie, one pillow, one blanket. Enough. Hungry? Done just half an hour. Next topic is very, very interesting. It is the more main fundamentals of electrochemistry were based on that topic. The ones who like problems will love it. The ones who don't like problem will also like it. Okay. I should tell in that way, right? Otherwise they will not study. Is it done, students? Yes. Write down. If the standard electrode potential, if the standard electrode potential, if the standard electrode potential of an electrode, if the standard electrode potential of an electrode is greater than 0, is greater than 0, then the reduced form is, then the reduced form is more stable, then the reduced form is more stable compared to hydrogen gas. The reduced form is more stable compared to hydrogen gas. Okay. So, see, one thing that you might be confused in both the experiments, what is this reduced form? What is reduced form? If I have copper and Cu2 plus, which is reduced form, which is oxidized form? Copper is reduced form, Cu2 plus is the oxidized one, correct? That much is clear. So, in the dialogue, what they have told, the reduced form. So, which is the reduced form? Copper, correct? No? The reduced form is more stable than the hydrogen. So, we observe that copper is more stable than hydrogen. Previously, what was it? Mg and Mg2 plus. Which is the reduced form here? Mg. So Mg is less stable compared to the hydrogen. So these were what they found from the experiments. Yes, sometimes this much brief would not be there in your textbook, but you understand all this. So if you realize one particular thing about this experiments was, what was the volume taken for both the electrolyte? 1 molar. So this kind of experiments is only possible when all the what electrolytes are of 1 molar concentration. Is it real in the real world? We do experiments with different concentrations, right? So a scientist called as Nernst came up with an equation called as Nernst equation, which is the most important topic from any case. And electrochemistry, whenever you hear in any future, you will remember Nernst equation. Write down the heading Nernst equation. I was waiting for this topic. Okay. Nernst equation, write down. Do you need the spelling? Nernst. Just give me a moment. Nernst equation. Write down the equation. Do not get scared by the equation. It's very easy. It's a scoring one, 4 marks question or 5 marks question. There is one small derivation. Okay. By end of 6:30, your perspective about Nernst equation will be different from what you have now. That much is enough. Irrespective of how difficult it is, at the end, if it is easy for you, that is enough, right? Write down. Did you write the equation? Now we are supposed to write what each terms mean, right? right? Where R stands for quickly. Who will tell me? Thank God. Gas constant. In bracket, write down the value 8.314 joule per Kelvin per mole. 8.314. Now quickly write down the other terms. What is T? Temperature in Kelvin. N. Listen here. This whole equation that we are having is for any of the reaction, correct? What is the basic reaction that we studied in Daniel cell? Zinc plus Zn plus Cu2 plus giving Zn2 plus Cu. This much is clear. Now tell me how many electrons were lost, how many electrons were gained in this whole process. Zinc2 plus copper 2 copper. 2 electrons. How can it be 4? How will it be 4? I told you number of electrons that are lost are the same things that are gained by them. That's why we don't see it, right? For the ones who forgot, I'll tell you. Zn gives Zn2 plus 2 electron. Copper 2 plus 2 electron gives copper. So when you add it, what will get cancelled? 2 electron gets cancelled, and then you get the equation Zn plus Cu2 plus getting Zn2 plus Cu. Now it is clear why it is 2 electrons and why don't we show the electrons here, because whatever I give you is taken by the other one. Yes. So what is the number of electrons lost or gained here? 2. Write down N stands for number of electrons participating where? In the redox reaction. Right. Now last one, who is this? Oh, we still have many. F stands for Faraday's constant. Have you heard of Faraday? Who is Faraday? Physics students. Faraday's constant. See, if it is a constant, it should have a value, correct? Write down 96487 coulombs per mole. 96487. It's like a number, but you don't have to remember that. I'll tell you why. 96487 coulomb per mole. Now what is left here? 2 species more, no? See, what is this and this, students? This is E cell. This is E naught cell. So I'm not making you write again. Just write what is M. What does this thing mean in chemistry? Concentration is written in square box. You have literally studied redox, no, last year? Yeah. I guess before you leave this institute, 1 month we have to do crash course on 11th standard before you write your what is it? Competitive exam. What will it be? It will be the concentration of M. M is given as solid, so it will be solid metal. Concentration of solid metal. And what is Mn plus? Concentration of metal in ionic form. Correct? Ionized form. Is this much clear? Yes. What is it? E Mn by N. Mn plus giving M, what kind of reaction is it? Reduction or oxidation? How many are saying reduction? How many are saying oxidation? There were N plus number of vacancies. Now there are no vacancies. So people have come or people have left? People have come. So gain of electrons is called as reduction. So E reduced. Everything what Nernst have told you is in terms of reduction. Okay. So this is E cell is equal to E naught. So just understand what does it mean. Minus RT by NF ln M by Mn plus. What does R stand for? R stands for gas constant. Then T stands for temperature. N stands for number of electrons. Then M, Faraday's constant F. The double bracket M stands for concentration of solid. Then Mn plus is your ionized ionized form. This much is understood. Now, can you tell me which amongst this R, T, and F will remain constant and which will remain, which will go on changing from reaction to reaction? No, no, only this term. Is R constant? Is T constant? No. What about N and F? F is constant. N and T will go on varying from reaction to reaction. But usually what we do is we take T, we consider T as 25 degrees Celsius. If 25 degrees Celsius, what will it be in Kelvin? 298, 273 plus 25. So write down, can I write this as E cell? E cell is equal to E naught cell minus R. What is it? 8.314 into, write down, this is at 25 degrees Celsius. What will be T? 298 divided by, keep N as such. What is F value? 487 into, now this is ln. You're all math students, right? Ln is nothing but log to the base E. Convert it into log to the base 10. Okay, in simple words, convert ln to log. What will we do? So studying maths, no? You didn't reach there. You're studying matrix now. Okay. There is something called as ln. Ln is nothing but log to the base E. Okay, this is exponential value. Ma'am will teach in detail. But log is nothing but log to the base 10. So you just have to understand that there is a value called as ln. Whenever we have to convert it into log, we have to multiply by 2.303. What is it? If I have ln, if I have to write log here, what should I do? I should multiply it by 2.303. Now what will it be? It will be log. Will that much will you be able to remember? Ln gets converted into log. What is the value? You didn't have integration last time. Differentiation in 11th standard. One by x ln x differentiation. Huh? Little. Okay. So means nothing is there. Huh? Come back. See, don't make me become the teacher I was in college. You know, you have to be very strict. Here at least it's class. So remember. So multiply this whole value and tell me the value quickly. Who will remain there? M divided by Mn plus. Now, always remember concentration of metallic solid will be equal to 1. So, this whole term will become equal to 1. So, you write this above this so that you can write it. Okay. Till you get 0.05915 divided by n. Multiply, I'll tell you, multiply 2.303 into 8.314 into 298 whole divided by 96487. What will you get? So your final equation is E cell is equal to E naught cell minus 0.0591 divided by n log of 1 by mn plus. Is this easy? You don't have to remember anything. This will be your consolidated Nernst equation. Write it till here quickly. I want to do a derivation. We still have time, right? How much more time? Half an hour? 28 minutes? So each minute is important. We'll make sure that 28 minutes is productive. How many of you have understood this? No? Should I explain? Which one should I explain? After? ಇದು ಅರ್ಥ ಆಗ್ಲಿಲ್ವಾ? This one. Always remember, see here there are two things. One is concentration of a whole metal solid. That is your zinc. What will this be? Mn plus Zn 2 plus. I'm just giving an example. Always remember concentration of a solid will be equal to 1, irrespective of whichever solid it is, copper, gold or anything, that is taken as unity. So it will be 1 divided by the ionized form. ಇದಕ್ಕೆ value ಇರುತ್ತೆ. Why? Electrode is dipped into a solution. So the solution will have a concentration. No. Till now we studied the concentration is 1 molar. But I told this reaction will be taking so that we can use different volume. That much is clear. Then we told that at 25 degrees Celsius, what will happen? At 25 degrees Celsius, those who don't know, to calculate Kelvin, degree Celsius plus 273. First chapter, 11th standard. 25 plus 273 gives 298 Kelvin. Yes. So multiply it in 8.314 into 298 into 2.303 divided by n into so much. What is 2.303 now? Ln getting converted into log, you have to multiply by 2.303. Any doubt till here? No? Done writing? Can I rub this? Can I rub this? I guess I should not have come to teaching. I can see sadness on your face to study. Done? Shall I rub, students? Write down the heading for a Daniell cell. For a Daniell cell. And write down the reaction that we have in a Daniell cell. What is the reaction that we normally take? Hello? What is the reaction? Zn plus Cu2 plus gives. Now, we will try to write the reaction, that is, we will try to write Nernst equation for both cathode as well as anode. Write down at cathode, who is the one in cathode? It is cathode. Who told zinc? It is copper, So it will be E. What was the reaction? Mn plus bar M or M bar Mn plus? In the Nernst equation. Mn plus bar M. So it should be Cu2 plus bar Cu is equal to E naught Cu2 plus bar Cu. Are you able to understand what I am writing? I am writing the same thing based on the equation. Minus RT divided by NF. Keep it in ln itself. Ln dash divided by dash. Now, what will be the value of N here? For this reaction, what will be the value of N? 2. So, can I write this as 2F? Yes. Now, who are the ones that are there as a solid and as a ionized form for a copper one? Copper solid divided by copper 2 plus. Can I consider whole thing as 1 by Cu2 plus? Yes. You can write it in bracket because when we are writing again, I will not write it as Cu by Cu2 plus. I will be writing it as only 1 by Cu2 plus. Clear? Why did that 1 come? It is a metal solid. So it will be 1. Now write it for anode. Quickly write it for anode without seeing the side. E Zn2 plus divided by Zn. See, usually you should have a doubt. Do you have any doubt by seeing this equation here, what I have written here? Thank God. What is it? It should be Zn bar Zn2 plus. But I told you Nernst equation is in the reduced form. So always it will write in the reduced form way. What is that? Zn2 plus bar Zn. That's it. Okay. I wanted that doubt to come. So it will be E naught Zn2 plus bar Zn minus RT by, what will be the value of N again? 2F ln 1 by Zn2 plus. I have written directly here. I hope you understand why I wrote 1. Yes? Huh? Why is it not Zn bar Zn2 plus? Because Nernst equation, what did he tell? He gave it as Mn plus bar M. So we are supposed to write the whole equation in terms of the reduced form. That's it. Done? Now we have learned something. Till here have you reached, students? Stop writing and focus here. We know E cell is equal to what? E cathode minus E anode. Now can you write the whole thing minus this thing? Right. So it will become E cell is equal to E naught Cu2 plus bar Cu minus RT by NF ln 1 by Cu2 plus minus, you can open the bracket. Should I open and close, or you know how it is done? Okay, right, I'll teach. E naught Zn2 plus bar Zn minus RT by 2F ln if you understand, everything is easy. If you don't, everything is difficult. Simple as that. If you by heart, I'll tell you will not remember even one single thing in your exam hall, irrespective of how good you are at by hearting. There will be one day when you will forget. Okay, can you listen here now? What is opening bracket? What is closing bracket? So E minus of this one. Can I write the same thing? It will be minus same. Now minus of minus will become plus. So when I open the bracket, this will be plus RT by 2F. Is this clear? No? Minus into minus will become plus, right? So I've opened the bracket. What is it? Ln? No. This is whole one set, right? If here there was plus, it would have become minus. But it is a same entity. Now, can we club similar people together? Who are the similar people here? E naught Cu2 plus bar Cu. Can I bring this one here? It will become E naught Zn2 plus bar Zn. Next, minus of RT divided by NF. Now I close the bracket. Check here. If I put a bracket here, this term will become ln 1 by Cu2 plus. What will happen to this plus now? Kantaiva. This is plus. Now if I put a bracket, I bring a minus charge outside, it will become plus, sorry, minus there. So it will be minus ln 1 by Zn2 plus. For the ones who have not understood, listen here. If I open this bracket, what will happen? It will be minus RT by NF ln 1 by Cu2 plus, correct? Minus of minus will become plus. So it will become plus RT by NF ln 1 by Zn2 plus, correct? Any doubt till here? Should I repeat anything? At least you're open enough to tell me, no? Yes, thank you. So this will become 2. Here also it will become 2. Okay? Good. Now, do you think you have seen this fellow somewhere? I have wrote the whole this minus this as E cell. So this minus this will become, then what? You should tell me then what? If this is cell, this will become E not cell, no? ಅರ್ಥಾಗಿಲ್ವಾ? Listen here. E Cu2 plus bar Cu minus E Zn2 plus bar Zn is nothing but E cathode minus E anode, which is E cell. Now E naught cathode minus E naught anode will become E naught cell. Are you all with me? So can I write E cell is equal to E naught cell, yes, minus RT by 2F. Now there is a small magic here. Now again, since you have not studied maths, ln A minus ln B will become ln A by B, ln X minus ln Y. See, whenever it is negative, it will be division. Whenever it is positive, it will become multiplication. Yes, this is basic maths which you are ready to study, that's fine. So, ln 1 by Cu2 plus minus ln 1 by Zn2 plus, what will it be? Ln 1 by Cu2 plus divided by 1 by Zn2 plus, correct? So, Zn will go up, 1 will get cancelled. ಇದು ಓಪನ್ ಮಾಡಿ ಬರಿಬೇಕಾ? ಅರ್ಥ ಆಗಿಲ್ವಾ ಇದು? So it will become 1 by Cu2 plus into Zn2 plus divided by 1. Any doubt till here? No. So can I write it as Zn2 plus divided by Cu2 plus concentration? Yes. So this will be your final. Yes. If I have to write in terms of at 25 degree, what will be the final reaction? E cell will be equal to E naught cell minus, what will be the value? What is the value that you got that time? If ln is converted into, oh sorry, nobody told. Ye ln unto, huh? You are about to say it's okay, I heard, huh? So it will become minus 0.0591 divided by 2 log of Zn2 plus divided by Cu2 plus. Huh? How log came? No, it was not there. Why did log come? When ln gets converted into log, I told you have to multiply it by 2.303. How did this value come? Go back. I multiplied RT and I multiplied 2.303. Where did the 2.303 come from? That also you write. Ln is equal to 2.303 log. And even write this one. Okay. Any doubt? I will explain once again, but you just write and finish it off. I wanted to finish 3 more topics, but see, if you are understanding, this is easy, right? Correct, no? If you tell to your subconscious mind that it is tough, it will always be tough. If you have freedom, just read a book called as Power of Your Subconscious Mind by Joseph Murphy. Any readers here? Huh? You have that book, have you read it? It's like you have a driving license and you don't drive. Done? Should I explain it again quickly? All of you listen here. Can you all listen? Where did we start? In a Daniell cell, we started from zinc and copper giving zinc and zinc 2 plus and copper. Now, what is the reaction at cathode? We know that at cathode, who is at cathode there? Copper. So we write the whole equation in terms of copper. Why it is, what is this concentration of copper is taken as 1? Because it is metal. Same thing I will write it for zinc. Now, ECU2 plus bar Cu minus EZN2 plus bar Zn is nothing but your E cell. So I will write it as E cell. Now the rest of things when you subtract, what will you get? ECU2 plus bar Cu minus RT by 2F minus the whole thing. Now who will you club together? The similar ones. Which are the similar ones? E naught and E naught cathode minus E naught anode. So what you are supposed to get? In E naught cell. Now, what are the rest? RT by 2F. In bracket you will take ln of 1 by CO2 plus minus 1 by ZA2 plus. So it will be written as ln A minus ln B will give you ln A by B. So can I write it as ZN2 plus by CO2 plus? Okay. Hello? Understanding? Yes, understood. Sure. Ln Zn2 plus divided by Cu2 plus. Now, how will I convert this into this number? 8.314 into T. I'm taking T as 25 degrees Celsius. So, it becomes 298 into ln is 2.303 log. So, into 2.303 divided by 2 into what is the value of F? Mobile number, what is it? 96487. So when I multiply the whole thing, I get it as 0.0591. See, from today onwards, whenever you are remembering Nernst equation, you will remember it as E cell is equal to E naught cell minus 0.0591 divided by N log of dash by dash. What is that dash by dash? I'll explain. Till this here is clear? Oh, take 1-2 minutes break. Huh? Huh? Lock. That's not lock. How much more minutes do we have? 11. Do you remember anything regarding equilibrium constant? It is in 11th standard. Skipped it? Imagine I was a doctor. I skipped my topics. Then what would happen to you if you come as a patient to me? Yes. Maybe for us it's okay. We have skipped that topic. But what will happen to a medical science student? Imagine you're going to a doctor who was COVID batch. Yeah? Do you remember anything you studied in COVID? No. Innocent. Write down this reaction AA plus BB gives CC plus DD. See, I'm not making fun of you or mocking you, but 11th is very important. Only if you understand 11th, you can understand 12th. See, I can just go on teaching this, but if you don't understand, then there is no point. Though I'll get my money, if you don't understand, then there is no point in me teaching here. Correct? AA plus BB gives CC plus DD. What is equilibrium constant or what is equilibrium? For the redox chapter or equilibrium chapter, when the rate of forward reaction was equal to rate of backward reaction. This is by heart. You know when I start the tune, the rate of, but you don't know when I ask what is equilibrium. What is equilibrium? Pendulum, have you seen? It will go from to fro, but that middle point that it comes, it's called as the equilibrium. So if I bring a reaction such as this reaction is in equilibrium now. How will I write equilibrium constant? Equilibrium constant is given as C, concentration of D divided by concentration of A, concentration of B. At least remember writing something like this. Concentration of products divided by concentration of reactants. Or okay, if you have forgotten, just remember equilibrium constant you get when in denominator you have your product and in numerator you have product, denominator you have reactant. Now what is this CDAB? Stoichiometric constant. Imagine you are having 2 mg2 plus. When I write it, I'll be writing it as mg2 plus square. Yes, that 2 will go and become square. Is it clear? Yes. So write down this reaction quickly. AA plus BB gives CC plus DD. If I write the Nernst equation for this, it will become E cell is equal to E naught cell minus RT by NF ln. Listen here, students. For the previous reaction, what did you write? Cu was given, sorry, reduction, right? Cu2 plus was giving Cu, which is the product? Listen here, which is the product? Copper, which is the reactant? Cu2 plus. That's why when I wrote, I might have written Cu divided by Cu2 plus, right? Whichever is in the product, I wrote it in the numerator. Sorry. Whichever is in the product, I wrote it in the numerator. Whichever is in the reactant, I wrote it in the denominator. Check your Daniell reaction final equation. Now, if I write this in terms of AABB by, sorry, CCDD divided by AABB, how will I write it? I will write it as concentration of copper into concentration of Zn2 plus divided by concentration of Zn into concentration of Cu2 plus. Correct, no? But what do we know about concentration of copper? Solid will be equal to 1. So can I cancel this? What will be Zn concentration of solid? Again 1. So in your final reaction you might have seen ln Zn2 plus divided by ln Cu2 plus. Is this clear from where it has come? So how will you write it here? You will write it as C to the power C, D to the power D, A to the power A, B to the power B. This is not needed. Write whatever I written in the top. If you want, you can write how that reaction has come. If this was written in this form, okay, write it as example. Example, E cell is equal to E naught cell minus RT by 2F ln. Any doubt? See, only when you understand you will have doubt. Your teachers might have told you only two people can have no doubt. Who are those? Either if you have understood completely or if you have not understood a thing. Are you able to match these two reactions and understand what exactly has happened? Product divided by reactant. And why did I cancel these two? It's a solid, it will be 1 1. That's why in the previous derivation, what you might have got is E cell is equal to E naught cell minus RT by 2F ln Zn2 plus divided by Cu2 plus. This one you might have solved and you might have got 0.0591. If 0.0591 comes, it will be ln or log? Log. Clear? Any doubt till here? I guess we might have to stop here. Yes? Time is up. 3-4 minutes. I will not waste that. Quickly start from where we have started today. Revise. Start. If I come late, I can waste. I didn't come late, so I will use the time. Correct, no? Standard C. Standard hydrogen electrode. What do you know about standard hydrogen electrode? Quickly. Who are the three species? Tell me that much. Platinum is solid. Hydrogen gas, H plus ion. Clear? What exactly is happening? Two reactions takes place. One is oxidation, one is reduction. One will act as cathode, one will act as anode. What is the electrode potential at both? 0. So that is done. Then it can act as a reference electrode. So we had two experiments. What is the first experiment? Taking magnesium. We know that magnesium value was somewhere around negative. So if it is negative, we'll take that as anode. So if it is anode, what reaction should take place? Oxidation, anox. So oxidation should take place. If it is oxidation, what is the reaction? Mg to Mg2 plus. So if this is oxidation or anode, what will happen to SHE? SHE will be a cathode. So you saw the reaction at the end, you have got it a positive value. So it will be more reducible or less, which will be more stable than hydrogen. Lastly, you have written a line, no? Since it is negative, hydrogen gas will be more stable compared to the reduced form. What was the reduced form? Mg, correct? Okay, then next one. What is the next experiment? For copper and SHE. So I told that copper can be taken as cathode and SHE is taken as anode. If copper is taken as cathode, what is the reaction that will take place? Reduction. So reduction means what to what? CO2 plus to CO. Very good. Then in SHE there will be oxidation. Yes. So from the whole reaction or the cell we got that the value of what is the voltage given there? 3.11. Okay. Then final value what you are getting, which is positive or negative? Positive. So if it is positive, what you have assumed is correct. That is positive value should always be cathode. So hence we have taken copper as cathode. Clear? Then we went on to Nernst. Why is the need for Nernst equation? Because till now we had taken all the concentration in 1 molar. Here I can put any concentration, right? I can write it as 0.001. I can find anywhere. So we started with Nernst equation. What is the equation? E E cell is equal to E naught cell minus RT by NF. Starting first one, ln M divided by what is R? What is T? What is F? This is what happens if I ask one next number of what is this? Number of electrons participating. What is F? Faraday's constant. Number 96487. Then what is N? Number of electrons participating in. Okay. M, concentration of M will always be equal to. Why? Because concentration of solid will always be 1. Then Mn plus will be the concentration of the ionized form. Clear? Then we went on to at 25 degrees Celsius, what should happen? Temperature will be 298. What else? R will be 8.314. F will be 96487. And lambda gets converted into log. So, you should multiply by 2.303. So, you multiplied and final answer will be 0.0591 divided by n. Now, the other one I will not repeat it again. You have already learned what happens in a Daniell cell. But only thing I want to know is what is ln A minus ln B? Ln A by B. Then one more thing what I want you to know is ln, how will you write this in terms of for the final answer? You will write product divided by the reactant. Why we are only considering the ionized one? Because this will become equal to 1. Now does everything make sense? Yes, any doubt? Next class I want you to study and come. The first thing once I enter the class, first 5 minutes you'll write the derivation of Daniell cell. The Nernst equation Daniell cell. Yes? Why are you worried? It's easy. You already learned, right? Yes? Okay, how many more minutes? Done. -1. Oh, I've taken 1 minute extra. Okay, so when is one day which you are having free? Can you check and tell me in your timetable? Any day is given as free day? All days are occupied. Sunday is not a free day. Students wait for Sunday to come. I don't want to get what is that called curse from students for calling you on Sundays, right? I'll let you know. Maybe someday if I want to make it till 7, or otherwise it's okay. You might lose 1 or 2 chemistry class. Or some other faculty might come and take. Okay, thank you students, you can leave.